Section 7.5, this is going to be the last section that we do for this chapter. There is a 7.6 to this chapter. We're started. There is a 7.6 to this chapter, but we're going to just skip that one. Okay, so this will be the last section of this chapter. So let's take a look. Start off with a triangle. Actually, two triangles. We're going to start off with two similar triangles. Now, they don't have to be drawn exactly like this. I'm just drawing them so that it looks pretty close to what it looks like in the book. Okay. Let's group this together, and then I'm going to copy. I'm going to paste it. There we go. Oops. Copy and paste. Now watch what I'm going to do. I'm going to take these two triangles right now. I copied and pasted. So what are they right now?
Similar.
Well, if I copied and pasted, they're exactly the same. So they're congruent to each other. Watch what I'm going to do. I'm going to grab the corner. I'm going to hit the Shift key. All right. What the Shift key does, it keeps everything in proportion. Did you know that? All right. It just makes it smaller, but it keeps the proportion of the sides exactly the same. So I have two similar triangles right here. Now what I'm going to do now is this. Let's draw this in a different color. I'm going to draw a, let's see, two triangles, the lengths of the chord, altitude, right. I'm going to draw an altitude of this triangle. So an altitude goes from an angle where? Does an altitude go to the midpoint? Does it go to one of these directly to the center, to the midpoint? Is that an altitude?
No, it goes
Straight down, is that the word you want to say?
Make it 90 degrees.
Perpendicular. Perpendicular, okay? Let's say perpendicular and not straight down, okay? I know what you're talking about when you say straight down, but to be a little bit more geometric, we're going to go straight down. All right, so altitude means perpendicular, okay? Why does that color look different than that one? It's the same color. Doesn't it look weird? That one's a little brighter than that one. Is that what it is? Okay, that's all right. So here's what we're going to do. Let's put some letters in here. Let's use, oops, what did I do? What's going on? There it is. Okay. No, it's fine. Alright. Alright, let's put some letters in here. Let's call this A and D and B and C. Alright? We'll call this one F and J. You guys watching? You shouldn't be talking. You should be writing this stuff down. This should be in your notes. So write this stuff down.
Is that C or E?
Which one? C. This is ABC, triangle ABC, and this is HGF. This altitude is AD, and this altitude is FJ. Alright, so I've got a box of tissue things up there. You can use those. They're soft. Oh, they're beautiful. They are. They're soft. You'll like them. Alright, here's what this thing says. We have three things that are very, very close to this. Alright, the first one is an altitude. So let's even write that down so we can remember. Altitude. Did I spell that right? Yep. These are altitudes. An altitude goes from an angle perpendicular to the opposite side. That's an altitude. So what we have here is we have things that are proportion. These two triangles right here are similar triangles. Okay, so they tell you right off the bat that the triangles are similar to each other. I'm going to put a little similar. Actually, what we could do is do this. Triangle ABC. This is given, okay, that triangle ABC is similar to, let's see, if two triangles are similar, yep, to, what is it? If I go ABC here, what would I call this one? FGH, good. Okay, so triangle FGH. So these triangles are similar to each other. Now, if the triangles are similar to each other, this is what this theorem basically says. They call it special segments of similar triangles. Okay, this is one of our special segments. We're going to have three of them. The first one is altitude, and then we're going to do two other ones. All right, so the first one is altitude. The altitude, let's see how they say that, are proportional to the lengths of the corresponding sides. The altitudes are proportional. So let's set up a proportion. So let's compare the altitudes. So I would compare AD to what?
FJ.
FJ, good. All right, because I'm comparing the altitudes to each other. Do you see that? So I take the two altitudes, compare them to each other, and what this theorem says is the altitudes are proportional to the corresponding sides. So what corresponding sides on this other triangle do we have? Let's say AB. Let's go AB. That's one of the sides of this big triangle. What side corresponds to AB on this little triangle? FG. Very good. What if you didn't really know that from the picture? I mean, you should be able to figure it out, but look. AB goes with what? FG. Do you see it? Because AB are the first two, FG are the first two of this one. Does that make sense? So even if you didn't see the picture, you knew that AB and FG are corresponding. So what other sides do you have? Yeah, let's call it AC. Is that all right? Okay, so if I go AC, again, looking up here, if I go AC, you have to go what? FH. You with me on that?
Mr. Hammer.
Yeah. And there's a third side, too. Let's do that first before you ask your question. What's the third side?
DB.
Well, that's not really a side of the whole entire triangle.
CB.
CB, all right, or BC. Let's call it BC. So if we go BC, what would this one be over here? GH. Okay, GH. It's a weird G. All right, do you see that? Look, this right here is the altitude.
That's in line.
All right, because it's this one and this one. So if I compare this to this, then I can compare all the corresponding sides to each other as well. Does that make sense? So that's not too hard, is it? And you can see what they're going to do. They're going to put some numbers in here, aren't they? Now, we might do an example after we finish all these, but just hang on to that. Because if I knew this side, and let's say I didn't know this side, but I knew AB and I knew FG, I should be able to solve for FJ. You get it? All right, so these would represent lengths. These would represent numbers. Thank you. All right, let's move on. So that was altitude. That's not too hard to see, is it? So I take the two altitudes, compare them to each other. What does that equal? It equals the corresponding sides compared to each other. So look, if I compared the big one to the little one, I got to compare the big side to the little side. You follow me? I can't go FJ to AD equals AB to FG. I can't go little to big and then go big to little. Does that make any sense at all?
Yeah.
Okay. So I'm going from the big one to the little one, and then this big side to this big side. This big side, I'm sorry, to the little side. And then this big side to this little side. That's not hard to see, is it? Okay. Let's do another one. And they draw the triangles so they look a little different. So let's do the same thing. All right. All right, Kaylee, you had a question. I'm sorry.
I was confused, but I understood it. I was confused how AD over FJ was AB to GF. Like I was confused, but
Yeah.
then I understood it.
Okay, good. Because you're comparing. You're
Yeah.
comparing
I
from
forgot that you have to. It has to be in proportion with corresponding sides.
the corresponding sides, right? I can't go like AB to FH.
I was wondering why you
Right.
did the side, and then I.
Yeah. And if you're not really sure, because remember, sometimes they're not drawn nice and pretty next to each other like that. Sometimes they'll take one, they'll take another one, they'll flip it around, right? And you can't really tell which one goes with what. So what do you go by? You go by this thing right here. All right, so look, AB goes with, or corresponds with, FG. BC corresponds with GH. AC corresponds with FH, okay?
Yeah.
So if you get a triangle and you know what triangle is similar to the other one, and you can't really tell by the sides because it's like twisted and flipped, and you're like, does that one go with this one? I'm not really sure. Then I would always go by this thing right here, the similarity statement. Remember that? Okay, that's what we call that
Will
thing.
they give us that, or do we have to?
They'll probably give it to you.
Okay.
Okay, or it depends. Sometimes they want you to figure it out. All right, it all depends. Let's do another one. We did altitude. Now we're going to do, let's see, angle bisectors. So now we're going to take two similar triangles and look at their angle bisectors. And you'll see some things that are very, very similar with all three of these things that we're going to do. Again, let me try to draw it so it looks like the problem in the book. Let it rip.
It's not coming.
Huh?
I just need to sleep.
Good. We won't care.
Don't you have that feeling ever, like where you have to?
That never happened to you?
Oh, did you could? Oh, I thought you wanted to.
She's talking about.
No, I'm not embarrassed to sneeze.
Oh, okay.
It's like
No.
Yes.
Yesterday,
Do you have your card?
I was about to sneeze, and I, like,
You got what?
and so
It's in your locker. You promised to bring it to me when you come back.
and I didn't sneeze.
So what happens if you don't bring it back? What can I do? Slap you around? Cliff says I can slap you around.
You get it tomorrow.
Tomorrow? Then it's not in your locker.
I guarantee it's there.
You guarantee? All right. Everybody heard that, right? Take a pass.
Heard what?
Dion said he's guaranteed his card is in his locker.
It's on YouTube. So we can always go back and check.
All right, here we go. Watch what we're going to do. Here's two triangles. What do you think we're going to do to one of these angles here? Let's say this angle. We're going to bisect it. Very good. So look, does that mean, listen now, does that mean we necessarily go to the midpoint of the opposite side? No, we're looking at this angle. See this angle right here, Joelle? We're looking at this angle. We're trying to split that angle into two equal angles. We just have to eyeball it. What do you think? About right in there somewhere?
Yeah.
That looks pretty close, doesn't it?
So we're just going straight down.
Okay, that's not straight down. We're bisecting this angle. I'm looking to bisect that angle. So this angle should equal this angle right here. It doesn't really matter where it hits right here, does it? I'm not trying to hit the middle of this. That's not what I'm trying to do. Okay, all I'm trying to do is bisect this angle, split it into two equal angles. And I want to do the same thing over here as well. Okay, so split that into two equal angles, probably around in here somewhere. Again, I'm just eyeballing it. But this angle should equal this angle right here. Again, why did I do that? Because I'm trying to find the angle bisectors of this triangle. Right? We've talked about that dozens and dozens of times. Okay, let's label this just the way they do in the book. Q, R, S, T, and K, L, M, and P. All right, here we go. Look, you saw something already with that, what do we call it?
Altitude.
Altitude, thank you. It slipped my mind.
Oh, I thought you were
I was asking you. I couldn't
like,
remember.
to see if we remember.
Well, that too, but I couldn't remember myself. At altitude, so now what are we doing? We're doing angle bisector, okay? So we're bisecting this angle. So what do you think? I am getting old, yes, I am. Look, what are we going to do with these bisectors right here? What do you think? We're going to make a proportion, exactly right. So let's make a proportion with our angle bisectors. So what would it be?
Angle RT.
Well, it's not angle.
Or bisector RT.
Well, we'll just say line segment, RT.
No.
RT. RT over what?
LP.
LP. Good. So that right there is my angle bisector. Everybody see that? Now, it should be proportional to the other sides of the triangle. So what are my other sides? Actually, let's do this. It's triangle.
No,
It's triangle QRS.
it's a K.
QRS is similar to KLM. All right. Watch, if you wanted to. Remember I said it could be flipped around and twisted and all that kind of stuff? Okay, watch this. Ooh. Now my letters are kind of crooked, but you get the idea. So look at that. It's all right, you don't have to. You can keep it the way it was. I'm just doing this. I'm just doing this to show you that you don't have to... Shh, listen to me. You don't have to write it like this. What I want you to see is if you can't really tell which one goes with what, always look up here, right? So look, I go RT, right? So my angle bisectors are in a ratio. So what are my other sides? Forget the triangles. Just look up here and look at the other sides. So I could go QR to what? To KL. And then what else? Let's do another side. RS. Yeah, let's go RS. And that has to correspond to what over here? LM. And then what's our other one?
QS.
QS. All right, so QS and KM. Good. Do you see that? I didn't even have to worry about looking at this, did I? Because that threw me off a little bit. I'm not really sure if this side goes with this side or if this one goes with this. I'm not really sure because that confused me when it got flipped around. But you can always go to this thing right here, and that tells you exactly what sides are corresponding to each other. You should have that by now, right? I mean, that's nothing new. We've talked about that a whole bunch before. Again, what is the first thing?
That's the bisector.
That's the angle bisector, all right? So we take the angle bisector, compare them to each other, and then we take the sides of the triangles, compare them as well, the corresponding sides. We good with that? All right, so we've done two things. How many did I say we were going to do?
Three.
Three. So what was the first one? Altitude. The second one? Angle bisector, okay? And then we're going to do another one, and it's another word that we've talked about in the past. Does anybody remember? What do you want to go? Green? Let's go green. How about the median? How about the median? Well, that's a good guess, Brooke. That's a good guess because when we talked about altitude, didn't you say circumcenter? Okay. Girls, don't. Shh. Christian. Come on, you're wasting my time. Hush. When you said circumcenter, all right, thank you. Dion was right. See, when they go to the bathroom, they have this student visa, and it's got a certain amount of punch mark, so they can only go to the bathroom so many times during a semester. So we punch it.
That's for the whole semester?
It's for a semester, yes. But if they didn't use one, if they didn't use many punches from first semester, they get to reuse their card, and so works out. All right, we still have 10 minutes. That's not our bell. Here we go. Let's do one more. Ready? Let's draw out two triangles. This is median. No, it's geometry median. What's the geometry median? Look, yeah, I gave you an example, didn't I? When we first talked about median, I said, remember that grassy part in the road, or the cement part in the middle of the road?
I need to see John Hamrick, please.
He is not in school today.
I can't hear you. I'm sorry.
All right.
I thought he was gonna reach
He is absent from school today.
You would think the office would know we're absent. Like, I can't.
What? Well, that's what she said. She says, "Why didn't I know he was absent?" I'm like, I don't know. Well, maybe the homeroom teacher didn't put the absences on teacherees, so it's not necessarily her fault. Well, it's spelled like that. Oops. Copy group. Okay, here we go. Let's label these things like we did before. Yeah, A, B, C, W, X, Y. All right, here we go. Let's do the median in a different color. Let's go to this nice orange color. Let's pay attention. We're going to the median. All right. How do we find the median of a triangle? You go. Let's say we're going to go from C. Again, I want to be consistent with the book. So we start from C. You could go from anywhere. You could go from A, B, or C. But they decided to go from C. All right. So if you go from C, where are you going to go? Are you going to split the angle? Are you going to bisect the angle? No, we've already done that. We've already done angle bisector. What's the difference between median and angle bisector?
You gotta split the whole thing.
We go where? To the... Give me a word. Give me a good word.
Perpendicular?
Not middle. Midpoint. Thank you. Come on. We said midpoint all year long, haven't we? So you go to the midpoint. Oh, why did it do that? I keep doing that. I have no idea why it does that.
Control Z.
I'm controlling Z.
Oh, yeah.
Oh, goodness. Get out of there. Why is it doing that?
Oh, man.
Control Z. Oh, it got rid of my W, X, Y's.
Control Z.
Alright, so here's my two triangles right here. What are we trying to do? Find the median, correct? So the median goes where? To the midpoint, which would be right there, of the opposite side, correct? So let's go this nice purple. So watch, if I go from C to that point right there, then that's the midpoint. So what is, that's what, CD they use. Alright, so CD would be the what? The
Median.
median, yeah. Big hints here. Alright, so let's do this. Let's go, let's find out where it is. It's right there. Okay. And so let's, again, yeah, we'll call that Z. And we're going right here to the midpoint, and we'll call that Z. So if this is a midpoint, then this side and this side are equal, and these two are equal as well. Okay? So that's a median. All this just to say something that we probably could figure out on our own anyway. Let's do that. Now, this is the third time we've done this. You should be catching on at this point. Would you agree? So what ratio are we going to set up?
DC.
Yeah, let's call it CD. I like to go in alphabetical order.
Y.
Actually, let's do this. What would we call this triangle? Let's call this triangle ABC, and this would be, if I call this ABC, what is this? WXY. Okay. So watch. Let's compare the two medians. All right. Let's find the ratio of the medians. CD to what? YZ. All right. So now, what do you think? It's got to be in proportion with all the corresponding sides, right? The median is going to be in proportion with all the other sides. So all we got to do is set up the corresponding sides, ratios of the corresponding sides. So let's go here to here. So we've done this before. Let's do it real quick. AB, that's supposed to be a B.
Equals
To WX. WX. And then what else? BC to XY. And AC to WY. All right. So there you go. Again, what was this thing right here? That was the median. Okay. I compared the two medians to each other. Now look, do you always have to compare the left one to the right one like we did, or the big one to the small one?
No, you just have
No, we just kind of did it. As long as you go the same way, because I could compare YZ to CD, couldn't I? But then I'd have to flip all the other ones as well. Make sense? All right, no big deal. I think we have time to maybe do an example here. So let's try one.
What time is it? 13.
I don't think so.
What time do we get?
I think so.
22.
All right, let's
Hey, Mr. Hammer.
Hey.
While you're doing this, can I please run to the ladies' room?
The little kids room.
I can't watch YouTube. I'll watch YouTube tonight.
Oh, yeah. Please go to the bathroom then.
I told you it view.
Kaylee, if it's an emergency, go.
It really
But
is.
get a card.
I have it here.
Oh,
Oh, psych.
I thought you said you didn't have a card.
I do somewhere.
Okay.
I just don't see what happens when you have a suitcase for a purse. Can't find it. Mr. Hamrick, I'm sorry. You can stamp my hand or something. I gotta go.
Where's my hole punch? Give it to
I
me.
just gotta go.
I'll hole punch your hand. That'd be good. If you lose your card, just put your hand out there and I'll take a piece of flesh out of your hand. Just kidding. I am just kidding. It's a joke.
No, that's on YouTube.
It's not on YouTube yet until I put it on there. I may edit that out. All right, here we go. Ready? Let's take a look at this. It says solve for x. Oh, I got to tell you where x is, darn. Oh, wait a minute. Sorry about this. Let me pause this and draw the other triangle. All right, here's our situation. This is actually, it took a lot longer to draw this thing out than it will to actually solve the problem, I think. So look what we have here. Let's actually do this. Let's draw our little, what do you call this? Our similarity statement. So what do you want to call this one? KLM? So if I call this KLM, I got to figure out what I have to call this down here. Now look, it's flipped around a little bit, isn't it? So look, if I go KLM, look what I went. I went one arc to two arcs to no arcs. Do you see it? So 1 to 2 to none. So what's this going to be called? X, Z, Y. Everybody see that? See, look, I went 1 to 2 to none, and I go 1 to 2 to none right here. It's got to be in that order. So now you can see which sides match up. Sometimes it's difficult just looking at it and saying, okay, did he flip it or did he twist it? I don't know if he just, I don't know if he just rotated it or he flipped it around like this. I don't know. So figure out what our statement is, our similarity statement, and then you should be good to go. So let's do this. What are these? I'm running out of time. Let me finish this up, then I'll take a question, okay? Watch. This right here goes from M perpendicular to this. So what do I call this thing? It's the altitude. It's the altitude. Okay, it's perpendicular. Perpendicular is altitude, okay?
Can you tell us the altitude by the 90-degree thing?
Yes, by the 90 degree. Remember, look, here's the ground. Here's an airplane. See that cool airplane? Wow. Okay? Now, look, when you're on an airplane, shh, hush. When you're on an airplane, the pilot says, okay, we'll be flying at an altitude of, whatever, 30,000 feet. What is the altitude? The altitude's not from here to here, is it? It's not from here to here. It's what?
Straight down.
Yeah, but not straight down what? It's perpendicular to the ground, okay? That's altitude. Remember that? Okay. So let's do this. The altitudes are in proportion with the corresponding sides. So let us set up a proportion. What is it? 16 to, not equals, 16 to what? To x, because this is the altitude and this is the altitude. Agreed? Now, it's equal to the corresponding sides. So let's do this one. Because we know this. We don't know any other sides, do we? So we have to use 20.
20 over 15.
Now, you'd think it was 15. Let's just make sure it is. Now, look what 20 is. 20 is opposite the angle with two arcs. Do you see it?
Yeah.
Okay, so what side is opposite the angle with two arcs here?
15.
The 15 is. So it is 15.
Or couldn't
Plus,
you
it's the
see
only
if it
other
only
side
had
that we
one
know. You could say what?
arc? Couldn't you just look and see that it only has one arc too?
Well, it's a side, though. It's a side that connects the one arc to the no arc. Do you see it? This is the side that connects the one arc to the no arc. You could look at it either way. Let's do this. Let's cross multiply. So 20x equals what? 16 times 15. And then what do you do here? Divide by 20. Tell you what, let's just simplify. We could do this without using a calculator, can't we? Watch, I'll show you. What goes into these? Let's go 20 and 15. What goes into 20 and 15? 5 goes into that what? 4 times. Into this? 3 times. What? 4 goes into this once. Into this what? 4. What is it? X is? How about 12? It's multiplication. 4 times 3. You didn't see
I
that?
thought we were adding. Sorry.
It's multiplication.
I don't know why.
No addition. It's multiplication. All right. Or if you wanted to, you could always use the trusty calculator. You have a calculator.
No.
Look, 16 times 15, okay, equals divided by what? 20, right? And there it is, 12, just like that. Okay. Well, we did it right here. You should do this. All right. Shouldn't rely on the calculator all the time. But there you go. There's an example of the kind of stuff that you're going to do. All right. So we are doing a worksheet tonight. We're doing a worksheet, and it's section 7.5. I know you do. I know you do. That's why I make them for you. All right. So that's due tomorrow. Have it done.